Have you ever wondered how the lights turn on with just a flick of a switch? It's all thanks to a giant, invisible network called the power grid. Think of it as the city's circulatory system, pumping electricity everywhere it needs to go. For over 100 years, this grid has worked pretty much the same way. But now, we're giving it a major upgrade. We're making it smarter. A smart grid isn't just a bunch of wires. It's an energy brain for our entire community. It uses computer sensors, cool technology to make our power system more reliable, more efficient, a whole lot greener. It's science in action, on a massive scale. Imagine a three-dimensional map of a bustling city. Now, let's overlay our smart grid on top of it. We can break this amazing system down into 5 main zones, each with a special job to do. Generation zone transmission and substation zone distribution zone, consumer zone control and communication zone. Each of these zones is connected, working together in a beautiful, complex dance. The old grid was mostly a one-way street. Power flowed from the big power plant straight to you. But the smart grid is a two-way conversation. It can send electricity out, but it can also receive information, and sometimes even electricity, back from consumers. This is possible because we've added smart devices all along the path. These devices talk to each other, sharing data about how much power is being used where it's needed most, if there are any problems along the way. It's like the grid has its own internet. This constant flow of information is what makes the grid smart. It allows the people who run the grid to see everything that's happening in real time. If a tree branch falls on a power line, they know about it instantly instead of waiting for someone to call. They can redirect power around the problem to keep your lights on. This digital upgrade helps prevent blackouts, saves energy, and prepares our cities for the future. It's a powerful idea. It's all powered by science, technology, engineering, math. Consider this. The grid is becoming a living, thinking network. Our energy journey starts in the generation zone. This is where we create the electricity that powers our world. Traditionally, this meant huge power plants burning coal, or natural gas plants, or nuclear reactors spinning giant turbines. These are often located far away from the city center. But in a smart grid, the family of power producers gets much bigger and more diverse. Vast fields of solar panels soaking up the sun, panels converting sunlight into electricity, towering wind turbines, blades spinning gracefully. Even homes can become mini power plants with rooftop solar, and businesses can too, with commercial rooftop systems. Once the electricity is generated, it's ready for a long trip. At the power plant, a step-up transformer increases the voltage. Think of it like putting water into a super high-pressure hose so it can travel far. This high-voltage electricity is then sent into the transmission zone. Giant metal towers march across the countryside. Thick cables ride high above the ground. These are the superhighways of our energy map, moving massive amounts of power. Substations are fenced-in areas filled with a maze of switches and circuit breakers.
Music licensing reimagined.
There's another transformer here, a step-down transformer. Its job is to lower the voltage to a safer, more manageable level. Think of it as taking the pressure down so the power can flow into smaller pipes. These substations are critical checkpoints, ensuring electricity is ready for the next stage. The smart grid makes this whole process more intelligent. Sensors on transmission lines can detect sags. They can track temperature changes or other issues that might signal a problem. This allows grid operators to act before a major failure happens. The grid can now better handle the variable nature of renewable energy. When the sun is shining brightly, the grid takes in lots of solar power. The wind is blowing strong.
Music licensing reimagined.
When it's cloudy or calm, the grid can switch to other sources, or even pull from large-scale battery storage systems. It's a dynamic, flexible system, always balancing supply and demand. After leaving the big substation, our electricity enters the distribution zone. If transmission lines are the highways, then distribution lines are the local streets, avenues that weave through our neighborhoods. These are the familiar power lines you see running along wooden poles in your backyard. or buried underground beneath the sidewalks. The voltage is stepped down again by smaller pole-mounted transformers, pad-mounted green transformers you might see in parks or on street corners. This brings the voltage down to the level that is safe to use in our homes and businesses. It's the final step before the power is delivered right to your door. This is where the grid gets personal, and it's also where some of the smartest technology is put to work. Throughout the distribution network, we have smart sensors and automated switches. These devices are the grid's eyes and ears on a local level. They constantly monitor the flow of electricity. If a fault occurs, say a car hits a utility pole, these smart switches can automatically isolate the damaged section of the grid. They can then reroute power from another direction to restore electricity to as many homes as possible, often in just seconds. This self-healing capability is a game changer, dramatically reducing the length and number of power outages. Finally, the electricity arrives at the consumer zone, which is where we all live and work. The gateway for electricity into your home is a device called a smart meter. This isn't your grandfather's old spinning dial meter. A smart meter is a digital, two-way communication device. It precisely measures how much electricity you're using and when you're using it. But more importantly, it sends that information back to the utility company automatically. No more waiting for someone to come read your meter.
Music licensing
This gives both
reimagined.
you and the utility a clear, real-time picture of energy consumption. This two-way communication unlocks amazing possibilities. With a smart meter, you can see your own energy usage on a phone app, helping you make smarter choices to save energy and money. For example, you might decide to run your dishwasher late at night when electricity demand is lower and prices might be cheaper. Some smart grids even allow for two-way power flow. If you have solar panels on your roof and they generate more electricity than you need, you can sell that extra power back to the grid. Your home becomes part of the solution, contributing clean energy for your neighbors to use. So what holds this whole incredible system together? That's the job of the control and communication zone. This isn't a single place, but a network of advanced software-secure communication channels, high-tech control centers. It's the brain and nervous system of the entire smart grid. In a central control room, engineers sit in front of massive screens, displaying a real-time digital map of the entire grid. They can see how much power is being generated, where it's flowing, and how much is being consumed all at once. It's like being an air traffic controller, but for electrons. This central command center receives a constant stream of data from all the sensors, smart meters, and automated switches spread across the grid. Powerful computer programs analyze this flood of information, looking for patterns predicting future energy needs and spotting potential problems before they happen. For example, if the system sees a heat wave is coming, it can anticipate a surge in air conditioner use and make sure there's enough power generation ready to meet that demand. This predictive ability helps keep the grid stable and prevents the system from becoming overloaded, which is what leads to blackouts. The communication part of this zone is just as important. The smart grid relies on a secure and fast network, like a private internet, to connect all its different parts. This network allows the control center to send commands out to the grid. For instance, operators can remotely open or close switches to reroute power, or they can adjust the output from different power plants to perfectly match the demand. This two-way conversation between the central brain and the devices in the field is what makes the grid so responsive, flexible, and resilient. It's a huge leap from the old grid, which was largely a manual and reactive system. Ultimately, the smart grid is about building a cleaner, more reliable, and more efficient energy future for everyone. By seamlessly integrating renewable energy sources like wind and solar, it helps us reduce our reliance on fossil fuels and fight climate change. By giving us real-time information and control, it empowers us to save energy and lower
Music
our bills.
licensing
And by
reimagined.
making the grid more resilient, it ensures that our communities have the power they need to thrive, even in the face of storms or other disruptions. The smart grid isn't just a technological marvel, it's a key ingredient for building the smart cities of tomorrow. Now that's science.
Artlist.io